Hello, my name is Ethan, and I'm going to be doing the Lesson 6 Laboratory Cloud Formation.
In this lesson, you will create clouds in a bottle. You will find the conditions that are best for creating a cloud in a bottle and then use the results from your experience to infer or learn what conditions are best for cloud formation in nature. Goals for this lesson: explain the differences in air temperature, amount of moisture, condensation nuclei, and pressure using data about geographic and topographic locations.
Okay.
You will need a 2-liter or a clear plastic bottle with lid. Show.
This is all we have. We don't have really a 2-liter. So we got a 50 milliliter, but that's still okay because everything that you can get. So it's Stater Brothers brand, and pretty much.
All right, a watch, matches, a beaker with at least room for 400 milliliters, and then you show the plastic container. All right. The key word for today that we're going to discover is dew point, the temperature at which water vapor begins or would begin to condense. Explore, investigate, but first safety. Be careful when using matches. They are flammable and can cause severe burns or start an unintended fire. Be careful when working with hot water. It can cause severe burns. Review the laboratory guidelines before conducting the lab. In this laboratory experiment, you will explore the formation of clouds. You will stimulate cloud formation in a bottle, but will discover the roles that temperature, altitude, humidity, and the pressure of condensation nuclei have on the formation of clouds. Okay, pour 200 milliliters of cold water into the 2-liter clear plastic bottle.
So we pour water in? Okay.
Okay, since you're using a small water bottle, we're going to use half of that amount of water, which would be about 100 milliliters of cold water. Fill it up in your plastic bottle.
So half of it.
No, pour all of that in there.
Oh, okay.
Screw the lid on tightly. Shake the bottle for 30 seconds.
1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000, 6 1,000, 7 1,000, 8 1,000, 9 1,000, 10 1,000, 11 1,000, 12 1,000, 13 1,000, 14,000, 15,000, 16,000, 17,000, 18,000, 19,000, 20,000, 21,000, 22,000, 23,000, 24,000, 25,000, 26,000, 27,000, 28,000, 29,000, 30.
Increase the pressure within the bottle by squeezing it and keeping it compressed for several seconds. Allow the air to expand by releasing the pressure.
Am I opening it? Did I open it? Oh.
Observe the air inside the bottle. It might help to hold the bottle up to a light source when making your observations. If the condensation becomes a problem on the sides of the bottle, roll the bottle to remove the condensation. Do not rush your observations. It may take several minutes for the clouds to form. Record your observations in the data table on the lab report. So put the lid on it. Give it a good shake quietly to yourself. Count to 30. Now squeeze it. Now set it there. Leave it alone. Leave it there for just a minute. And we're going to let it sit for a second, okay? All right. Do you see any condensation collecting? I don't.
Yeah, not me.
Okay, so we've observed that there's no condensation buildup, right?
Yeah.
All right. So now we're going to do the cold water plus match.
Okay.
Unscrew the cap from the bottle. Gently tip the bottle so that the top is pointing down, but no water runs out.
So it means like those kind of, like how?
You're gonna take it like this, just like that, until no water runs out.
Okay.
So you're gonna hold it to that point. Make sure no water runs out.
Right.
Okay. Carefully let it match. Blow it out and hold the smoking match inside the bottle for 3 seconds. Now it's important to get as much smoke into the bottle as possible. Replace the cap quickly. Squeeze and release the pressure in the bottle as you did in part A, step 4. Record your observations on the data table on your lab report. Okay, so I'll hold it, you light a match, and then you put that smoking match inside there as quickly as you can to fill it up for a few seconds.
Okay, 1, 2, 3.
Blow it out. Put it inside quickly. No.
Oh, I didn't. I'm sorry.
Hold the match there for a few seconds
Oh, yeah, I get it now.
to put the smoke inside, okay?
Okay.
Blow it out. Where's the cap? Okay, light another match, please.
Sorry.
I'll blow it out.
Okay.
Okay, now squeeze it. Now set it aside.
I see a little bit of condensation built up.
The bottle's expanding, isn't it?
Yeah. So you can you can barely see it, you know, but it's like you can tell that there's like some like smoke or like some smog in there.
Okay.
Yeah, it's still expanding. Let me just get another match out just in case.
Okay, now you're gonna do hot water.
Okay.
Okay, so let's pour that out.
Is it almost hot?
Almost. I'll let you know when it's done, okay? Okay, so go ahead and fill it up to about right there with hot water, please.
Okay.
Okay, that's good.
Okay.
Alright, now put the cap on it and tighten it. Shake the bottle for 30 seconds, count to yourself.
Okay.
Okay, now squeeze it. Alright, let go.
I can see condensation. As soon as I squeezed it, I can see it.
Alright.
Oh yeah, look at it. It looks a little bit more like smoggy.
Cloudy?
Yeah, cloudy. And this one's B, right? Or is it C?
This one's C for hot water.
Yeah, this one's C for hot water. The other one was C. I meant.
Okay, so now what we're going to do is unscrew the cap from that bottle, gently tip the bottle so that the top is pointing down but no water runs out.
I'm gonna do it like we did before.
Yes, please.
Okay.
Grab the cap with your hand and get ready.
Okay.
Tell you when. Okay, the cap on.
And squeeze.
Yes.
Yep, there you go. There's some cloud condensation going through. Look at that.
Yeah.
That is actually cool. So cold water doesn't work really well when you're because it doesn't really build up as much heat. I meant like a lot of dew point, like at that dew point. But with and it does little with the matches being blown out and the smoke. But with hot water, it was capable of doing that because it wasn't dependent on the matches. Because it got to this point, but a little bit more lighter. So yeah.
Okay, so clouds form whenever the air temperature falls to the dew point and condensation nuclei are present. The question in this lab is why does the air cool? Let's take a look. So, what conditions are best for cloud formation? In this lesson, you will create clouds in a bottle. You will find the conditions that are best for creating a cloud in a bottle, and then use the results from your experiment to infer what conditions are best for formation in nature. Explore. Clouds form when water vapor in the air turns to liquid, water, or ice crystals. The process of condensation changes water vapor to liquid or ice. Condensation occurs because cold air holds less water vapor than warm air. As air cools, the amount of water it can hold decreases. Air may cool because it expands or because it rises to a higher elevation. In this laboratory, you created clouds in a bottle. And then you altered the conditions to simulate changes in pressure and an evaluation so that you could begin to explore the conditions in which clouds were formed. Dew point is critical when considering the formation of clouds. Dew point is the temperature at which condensation begins. In some cases, the dew point will be below the freezing point. If, in this case, when the water vapor condenses, it will change directly to ice crystals. A cloud is actually a mass of millions of ice crystals or water droplets. Dew point, the temperature at which water vapor begins or would begin to condense. Condensation nuclei are needed for clouds to form. When water vapor condenses, there must be tiny particles present to form the clouds. These tiny particles are needed for the water particles to condense on. Many times these particles, called condensation nuclei, are salt crystals, dust, or smoke. Water vapor can also condense on solid objects such as grass or leaves. You know this as dew or frost. Clouds form whenever the air temperature falls to the dew point and condensation nuclei are present. The question is in this lab is, why does the air cool?